here we have this sequence, and we're looking for a pattern. Now, if I add 2 to 2, I get 4, but if I add 2 to 4 again, I don't get 8. So this is not an adding pattern. This must be a multiplying pattern. Okay, we are multiplying by 2 between each of these stages here. So when your pattern is multiplication, that is a geometric sequence. The recursive equation is f of n, which represents the number in the nth position. This is the first position, second, third, fourth, and so on. We get that by taking the number in the position before that, f of n minus 1, and then multiplying by 2. And every time we have a recursive equation, we should indicate our starting value. We are starting here with f of 1 equaling 2. The first number is 2. Okay, and then to get our explicit equation, we'll go ahead and create a table of values so we can see our pattern. So n and f of n. So the first term is 2, the second is 4, the third is 8, and the fourth is 16. But we'll want to write these numbers using the pattern, which is multiplying by 2. So instead of writing this as 4, we'll write it as 2 times 2. And instead of writing this as 8, we'll write it as 2 times 2 times 2. Okay, and then here, again, take the previous thing and then multiply by 2. And then we'll write this in a condensed form. We see here repeated multiplication. And in math, one way that we can notate repeated multiplication is by using exponents. So here I am multiplying 2 by itself 4 times. That's 2 raised to the 4. Here I'm multiplying 2 by itself 3 times. That's 2 to the 3. Here we have 2 to the 2, and of course up there that's just 2 to the 1. So we see here that we see a pattern arising. We've got 2 raised to a number. So for the nth spot, we will have 2 raised to something. Now that something is different each time, so that's where we're going to use our variable. And we see that that exponent happens to be the same as the number over here. So if I'm calling the number over here n, then the exponent will have to be n. So that's my explicit equation, is f of n equals 2 raised to the n.